learning target, you will multiply and divide radical expressions. So what this bunch of nonsense means, don't get scared with all the letters. So all that means is if the index is the same, you can multiply the radicand and get that. So as long as the index are the same. If this one was 2 and this one was 2, then I could multiply A times B and get that. But if you had 2 and 3, then you can't do that. That's a big no-no. If you had 3 and 3, yes, but again, they have to be the same. And the same goes for the division. If the index are the same, you can divide those numbers and put them all under one root. Let's see what that looks like for us right here. So what's outside of the root stays outside. So this is telling us to multiply, and that's what we're going to do. This is just like our super duper example right here. So we have two square roots, two different numbers. That means I can just flat out multiply those two numbers. So 5 times 3, 15, square root of 25 times 24. Handy dandy calculator. 24 times 8, 192. Now, it would be crazy if that's all we had to do, but now, going to what we just did yesterday, we have to simplify this root. So here we go, 192. Divide by 2. You get 96. Divide by 2, 48. Divide by 2, 24. 2 and 12. 2 and 6. And 2 and 3. You're going to make groups of 2 because the index is 2. It's a square root. When you don't have anything, the index is 2. So groups of 2. 2 squared. 2 squared, 2 squared, and 3. That means the only one that will remain under the square root is the 3. All the others will get out of the square root. So you only have, well, the 15 that was there from before, times, now you got 2 times 2 times 2 from whatever the 92 was. 2 times 2, 4. Times 2, 8, square root of 3. 15 is this 15. Now 8 square root of 3 is the same thing as square root of 192 is the same thing as 8 square root of 3. Square root of 192 is the same thing as 8 square root of 3. Now we can multiply these two dudes right there. 15 times 8. So 120 square root of 3. Done. I have 2 more. Now, this is the second general formula right there. The indexes are the same, so I can just go ahead and rewrite them as 1 cubic root of 48 over 2. 48 divided by 2 this looks funny, sorry, but okay, so now we're going to do the prime factorization right there of 24. We're going to make groups of 3. because of the index. 1, 2, 3, and 3. So the only one that will remain under the root is the 3. The 2 is going to go outside. So that will be the same thing as 2 cubic root of 3. Number 3, we're adding letters to it. All right. So I'm going to multiply everything. So multiply the coefficients, and we're going to add the exponents. Fourth root, 4 times 8, 32. Add the exponents for A, you get 6. Add the exponents for B, you get 15. You're going to have to do the prime factorization for 32, and you're going to have to make groups of 4. One, 2, 3, 4, and 2. Two to the 4th power and 2. The only one that will remain under the root is this 2, and this one will be on the outside. Make groups of 4 right there. So a to the 6th power, it's a to the 4th, a to the 2nd, because I know if I add them up, I get 6. 15, I get 4, it's B, sorry. 4 is 8, 4 is 12, and 3 is 15. The only one that will remain is the last one. So here we go, putting it all together. This, all of them are going to be on the outside of the root, including the 2 right there that you just got. 2. Only this A is outside. B, we got 1, 2, 3B outside. B to the 3rd power. 4th root of, you got this 2. You got this A squared. And you got this B cubed. The last one, you can just put that in the calculator, or you can do it by hand. That's your choice. But if you don't know how to put that in the calculator, when we're taking the quiz, I'm not going to show you how to put that in the calculator during the quiz. So right there, fraction 27 over 8, booyah. Just straight from me to you, easiest problem of all, 3 over 2. If you don't know, slow down the video to see all the keystrokes, but if you had me first semester, you know exactly how to put a fraction in, and for you to put the cubic root, you go math, there's cubic root right there.